let's just repeat some of the things we already talked about in the first part of this level about the mixer, and that is the controls in the mixer that we have for the gain. So we do have the control over gain by pulling this triangle up and down with our mouse. We can also click this number right here and pull that up and down with our mouse. We can just click that number value for the gain fader, and we can actually use our keyboard arrows up and down and get changes of 1 dB per click. So every time I press my up button on my keyboard, I get 1 dB up, and pressing down, I get 1 dB down. If I use shift as a modifier and then I press up and down, I get 0.1 dB of a change. So you can use your keyboard, as we already mentioned, to mix. And of course, we have this peak value display right here that you can use to actually see what is the highest peak you had since your song was playing last time. Now we're going to talk about the meters more during this lesson. Once I play this track, I'm just going to pull the volume down so you can hear me over the music. Now, as you can see, each one of these, and we mentioned this before in the lessons before, has a meter of volume for each one of the channels, as well as the master channel, of course, and it does react to the gain changes we make with the gain fader on the channel. But as you can see, there are two distinct different ones. The upper one that reaches more and the lower one. Now, what are these and what are they used for? Now, the first thing I think it's very important to explain is the peak meter, the PPM, peak program meter. This value shows you the direct value of any sample at any time. So if you remember, our digitized signal has all of those values taken, all of those measurements, 44,100 times a second. Well, this is going to show you the highest one at any point. So it's not going to skip either one. If there is any one of those that goes over 0 and clips, this would definitely show you that it does like that. See, it will show you red at any point if any of the values ever reached 0 or crossed over 0. So that peak value is actually the real-time measurement of what the signal is actually doing. So the real-time measurement of its level. This is very useful for some things, as determining if we are clipping, if there is anything going into red. Okay, so let's talk about clipping. What is clipping actually? Well, once we discussed digitalization of audio signals, we talked about the measurement for it and its decibel full scale. So meaning that it is measured in decibels, but the digital scale has a maximum that cannot be surpassed. So in an analog world, if we just wanted a stronger signal, there would be more voltage, and with more voltage, we would need to have a thicker cable. And that way we could actually transfer as much power as we want, as long as we had cables thick enough to withstand that electrical power. Now, in digital, since this is all digitalized, our maximum is 0 dB full scale, meaning that the minimum is minus infinite and the maximum is 0. So all the values that measure the digital audio signal go from minus infinite to 0. So all of them are negative values, actually. Now, if you thought about clipping, what that would entice is this sine wave signal being amplified so much that there was no more room to digitalize the entire waveform. And it would actually look just like this. Its peaks that were actually hills would get cut off, and we would get this kind of a signal. So we would get a flat line everywhere where we didn't have any more room for digitalization. All of those values that were in this nice little peak would get stuck onto our 0 value, onto our maximum value, and they would just stay there. And that's it. So we would get a signal looking just like that. Now, let me try to demonstrate that for you and actually amplify this even a lot more. So I'm going to amplify that. I'm going to make it loop and solo that. And I'm going to export that. export that is like File, Export Audio, or Control-Shift-R. I always suggest you use shortcuts. I'm just gonna put this on my desktop. Now let me re-import that file back into this project. Okay, now that we have this re-exported sine wave in our song again, let me just add another audio track so we can compare those. So put that right there underneath. So let's see what the differences are between these two. Now the first one is actually mono, second one is stereo, but if we just look at it, you see the original WAV file, if I just go back on its volume, is normal, but the one that we just had exported has turned into a square-shaped waveform. So it's actually no longer a sine wave. If we look at it, it's a square-shaped waveform, and even if I pull the volume down, it's still square-shaped. So you see, I have actually ruined it by making it clip. And clipping means clipping off a piece of the waveform that cannot be digitized anymore because there is no more room. There is no more digital resolution where we could actually fit that information. So everything gets stuck, as I told you, to the 0 dB, to the maximum of the full scale level that we have for digitizing audio. So if we do something like that, you see the difference between the sound of these two is going to be quite drastic. Let me play this for you. So the sine wave first, and now the square wave. See, that's way different. So we have essentially ruined the sound. And imagine this being a voice, a guitar. So having anything clip, having anything go into red is going to be bad. Now, where this is going to actually make a difference is if your master track is clipping. Everything before the master track, like all of the tracks in Ableton, they actually do get a bit depth of, I think, an internal processing of 32-bit or 64-bit even, and then there is room for you to go over 0. But once that goes into the master track, if you don't lower the volume of the master track when you're exporting, everything is going to be clipping. If at any point our master track goes into 0 or clips, appears red right here, this is what's going to be essentially happening. We're going to have a piece of our audio being digitized wrongly. So it's going to clip and there will be no space for it to be digitalized properly. Okay, I'm going to prepare you for the demonstration. I'm going to remove these two sine waves that we don't need anymore. It's not the song actually. I'm going to remove this looping. Okay, so I'm going to play the song at 0 and I'm going to up the volume of every channel in the track so that you see how it's going to be clipping. Well, you could see clearly that the meter of the master track is actually clipping, and that is a clear indicator that you're trying to digitalize audio where it can't fit your full scale resolution. Believe me, the solution to just pull down the volume on the master track, that's okay, but you don't really want to do that. What you do want to do is have reasonable volume for each one of your tracks that goes into the master channel so that even when the master track is always at 0, you never clip. So you leave always enough headroom, and we call it headroom since that's the space above the highest peak in your signal up to the 0 dB of full scale. So that's the space you leave when you actually pull down the volume on, let's say, this impact sound or on this crash, so that even if it's really, you see, loud, occupying the full resolution of this file, when I pull it down 16 dB and all of these tracks play, nothing on this track is going to be clipping. And that way I leave enough headroom, so enough room above the maximum peak of the entire sum of this whole track, so that I never have any clipping, I never have any digital clipping problems. So let's talk about the other meter. This one, the lower one, is actually an RMS meter, root mean square. So the RMS meter, root mean square, is actually an average value of the signal. So the average volume reading. As the peak meter is very fast and reacts to each sample in the signal, the average meter is going to actually round up, let's say, 300 milliseconds of all of those values in a row, of all of those 44,100 of them, add them up and divide them by the number of samples, actually giving us an average value for the signal, which is, for a human ear, a much better visual representation of the volume, of the loudness of that signal. So if we had a sound that is really percussive, like something in the drums, most probably, let me find, let's say, a snare, you can see that in the snare, the signal reaches a really high point right there, but its loudness is really low, a lot lower. That's 12, more than 12, like almost 18 decibel difference in the actual loudness, the actual volume perception, and where it actually reaches with the peak of its highest point. So that snare, when it actually plays, and we can see that snare right there, it's made out of 3 snares here, but that snare actually has a really high peak in its very beginning because it's a percussive element, but that peak is very short in duration, meaning that it doesn't give it so much loudness. For a human ear, loudness is also dependent on time. So it's dependent on the duration of the sound. So something really loud but really short is not perceived as just as loud as something maybe less loud but lasting a bit longer. So this averaging meter, the lower one on each one of the channels, really helps us determine how loud something appears to be when heard through a human ear. Now you have these meters integrated in Ableton. So you have the real-time PPM, peak program meter, that shows us each and every sample's maximum value in that sound playing on that channel. And you have the averaging meter, the RMS meter, root mean square meter, which shows you the actual perceived loudness of the sound. Now there are many more variations to those meters that we use today, with many different standards being applied to those. But we get to those in further courses like mixing and mastering course, where we actually talk about many different kinds of metering. So in conclusion, it's very important for you to grasp that in each one of these meters, we have 2 values displayed. The maximum peak value that the sample reaches at any point, the sound actually, each sample in that sound reaches at any point, and the average meter, RMS. It's called RMS, root mean square.